Okay, so let's talk about calculating entropy change for phase transitions. So this is only for phase transitions. You cannot calculate entropy change for other situations this way. Only phase transitions, which means you have the same substance, you're just going from a liquid to a solid, or a liquid to a gas, or a solid to a gas, whatever. But you're not changing the identity of the substance, you're only changing the phase. So the formula for the entropy change for phase transitions is delta S equals Q, the heat, over T. So let's break this down a little bit. So delta S, this is the entropy change. Q, this is going to be the heat, but at the phase transition. So remember, the heat of the phase transition, these are special heats. So the heat of a phase transition, if you were going from, say, a solid to a liquid, that would be the heat of fusion. Actually, it would be either way, between a solid or a liquid, either way. But if you were melting, it would be one sign. If it was freezing, it would be another sign. If it was between a liquid and a gas, that would be the heat of vaporization. And one that we didn't really talk about, but the same thing applies, is between a solid and a gas. So this totally skips the liquid phase. This would be called the heat of sublimation. So this would be like dry ice would be an example of this, where it's solid carbon dioxide and it goes straight to gaseous carbon dioxide. It totally skips that liquid phase. So these are some examples, but whatever would go here, this Q, this heat, is going to be one of these. It's going to be probably, these are the two most common, the heat of fusion or the heat of vaporization. And then T, this is going to be the temperature in Kelvin. Because remember, these phase transition, these heats of fusion, vaporization, or sublimation, these are going to be in kilojoules per mole. Delta S, the entropy change is going to be joules per mole Kelvin. So this is why the temperature needs to be in Kelvin. We are going to need to adjust for this, because the entropy change that we're ultimately solving for is going to be in joules per mole, but this will have been in kilojoules per mole. So we'll need to change one of these. This is a pretty common mistake, students not remembering that these two have different units, or forgetting to change the temperature to Kelvin if it's given to you in Celsius. So let's look at an example. So this one says acetone is a volatile solvent. Volatile means it evaporates quickly. It goes from a liquid to a gas quickly. It's a nail polish remover. It says the standard enthalpy of formation of the liquid is, hang on just a second. It gives us the heat of fusion, the heat of vaporization for acetone, from a liquid to a vapor. So I'm going to have, here's acetone. And the heat of vaporization is 31 kilojoules per mole. It also tells you that the temperature at which this is happening, so this would be the boiling point essentially, because it's the temperature where we're going from a liquid to a gas, is 25 degrees Celsius. And it says, what is the entropy change of this phase transition? And again, the phase transition, you know, is from a liquid to a gas because it is vaporizing. So you want to know, what is the entropy change for the vaporization of acetone? You're given the heat of vaporization, you're given the temperature, you're solving for delta S. So I'm going to say delta S equals Q, which in this example is going to be the heat of vaporization. And I'm going to go ahead and convert this to joules because I know I want my entropy in joules. So I know there are 1,000 joules in 1 kilojoule. So that's going to be the same as 3.1 times 10 to the 4th joules per mole. If I change 31 kilojoules times 1,000, and then I put it in scientific notation, 1, 2, 3, 4, 3.1 times 10 to the 4th joules. And then this also needs to be converted to Kelvin. So now I'm going to say that the entropy change is going to be 3.1 times 10 to the 4th joules per mole over 298 Kelvin. So I'm just literally going to divide these, and I'm going to get delta S, the entropy change, is 104 joules per mole Kelvin if I have 1 mole of this. This is joules per mole, yes. So that's the entropy change for 1 mole of acetone vaporizing. So this is a positive number. So you don't need to show the positive. If you just say 104, it's implied that it's a positive number. But does this make sense? If the entropy change is positive, then that means disorder increased. And is that what happened? Yes, because this is a vaporization. Essentially what's happening is you're taking the acetone liquid and it's being converted to a gas. So you're going from 1 mole of a liquid to 1 mole of a gas. This should give you an entropy change that's positive. And you see that the math there does make sense. So I'm just going to tell you that there will be some questions probably on the SmartWorks homework and on the exam where you're going to be asked to solve for either the boiling point or the melting point when you're given the entropy change and you're given the heat of the phase transition. So for example, if I told you, it would look like this. If I said the entropy change of the vaporization of acetone is 104 joules per mole Kelvin, and the heat of vaporization is 31 kilojoules per mole, what is the boiling point of acetone? So essentially you're solving for the temperature, because the temperature here in this example is the temperature of the phase transition. So remember, if you're doing the heat of fusion, you're going between a solid and a liquid. So this would be either the melting or the freezing point, depending on which way you're going. If you're being asked about the heat of vaporization, you're going between a liquid and a gas, depending on which way you're going. This would either be the boiling point or I guess you could call it the condensation point. So just don't be confused by these different terms. Just think about what it's asking you. If it asks you what is the boiling point of something, and it gives you the entropy change in the heat of fusion, you can use this relationship to solve for temperature. It would be the same exact thing that we just did. Just remember that temperature that you're solving for is going to be in Kelvin. So if it's being asked for in Fahrenheit or Celsius, you'll just need to convert it. So again, this formula only works for a phase transition. So if you're melting something, boiling something, freezing something, you can only solve for the enthalpy change of the phase transition using this relationship.